Hello, grade 8s. So last lesson we had a look at the test practice, and then for some of you, when you finished the test practice early, you had the time to move on to the problem solving questions on the following pages, but we didn't have time to go through all of the answers. So I will be doing a video response to all of the answers of this problem solving question. So if you have done the questions, then you may check the answers, you can check your solutions, and if there's any of the questions that you didn't understand, you can check how to do them. I will be explaining in full detail. You don't have to watch the full video. You can jump to whichever question that you would want to go to. So I'm going to start off with question 1. I think I did go through the answers, but I will still do it again. So question 1 over here says that there is a survey. Not a survey. In general, the popularity of the colors are shown in the pie chart. So there's red, black, blue, green, white, silver, and others. Those are shown in percentages. And so we want to know of 200 new automobiles in a parking lot, how many would you expect to be blue or black? So first of all, we want to find the probability of blue or black. We want to find a combined probability. And so these are disjoint events, meaning that you just have to add the two probabilities together. So that would be a probability of blue plus the probability of black. So these will be the two probabilities added together. And so blue is 10% and black is 11%. And once you add them together, you will have 21%. So 21% of cars will be either blue or black. And then now we have to project it onto 200 cars in a parking lot. So of 200, so 200 multiplied by 21%. And so if we have to show our working out, I can show it 200 times 0.21. We can use long multiplication. So 1 times 0, 0, 2, and then that's 0, 0, 4. Add them together, that's 0, 0, 2, 4, 2 decimal places, so move it back 2 decimal places. So in the end, we will have 42 cars. So we will expect 42 cars to be either blue or black. So that's question 1. Then for question 2, if a parking lot has 30 new cars that are red, so 30 are red, and we know that 12% of cars are red. And so if we want to think of it that way, we want to find the number of cars in the parking lot. So how many cars are new in the parking lot? So we want to let X be, let me just move this away. Let X be the number of new cars. And so the number of new cars times 12%, so I would say X multiplied by 12%, which is 0.12, is equal to 30. So make sure we understand how to set an equation. The number of new cars multiplied by the percentage that are red, which is 12%, that will give us, 30 new cars, not 300. I wrote the wrong number there. And so now we just have to find X. X is equal to 30 divided by 0.12. In order to find this, all I have to do is move the decimal 2 places, and so I can move the decimal 2 more places over here. So that will be equal to 3,000 over 12. And so I can divide top and bottom by 3. That will be 1,000 over 12 divided by 3 is 4. And so 100 divided by 4 is equal to 250. So there are 250 new cars in the parking lot. Moving on to question 3. We have each box of your favorite cereal contains one of 2 action figures from a movie. A supermarket has 50 boxes of cereal. There is an action figure of a villain in 20 of the boxes. So first of all, we want to find out the number of villains is equal to, the probability of villain is going to be 20 out of the 50 boxes. So in general, that is 2 out of 5. And so let's continue with the question. It says the remainder of the box contains heroes. So what is the probability that you randomly choose a box of cereal that has the action figure of a hero? So it's either villain or hero. These are complementary events. And so the probability of hero is equal to 1 minus the probability of villain, which will be 1 minus 2 over 5, which is equal to 3 over 5 in the end. So question 4, moving on. It says a frozen yogurt shop allows customers to choose 2 toppings from 10 possible choices and combine these with their choice from 4 flavors of frozen yogurt. So the store has given names to 30 of the most popular combinations. What percent of the possible choices of 2 toppings and 1 frozen yogurt flavor have names? So this question is actually a mix of combinations, permutation, counting theory, and also probability. So there's a mix of everything in this. So let's understand what is going on in this question first. So the shop allows customers to choose 2 toppings from 10 possible choices. So we're looking at a combination of toppings. And then on top of toppings, there's also, they can choose from 4 flavors of frozen yogurt. So they can choose 1 out of 4. So if we combine them all together, what are the total possible number of ways to make yogurt? So we have toppings over here, and then we also have flavor of the frozen yogurt. Flavor. And so in terms of topping, we can choose 2 toppings out of 10. So it's going to be 10 times 9 divided by 2 times 1. And so we can simplify this to 5 times 9, which is equal to 45 different combinations of toppings. And then in terms of flavor, we can choose from 4 flavors. So we need to multiply that by 4. So in the end, there is 45 times 4, which is 180 different choices for frozen yogurt, for choosing your frozen yogurt. Now we want to find a percent, what percent of these 180 different choices have names? Well, only 30 of the most popular combinations have names. So 30 out of 180 different choices have names. So the numbers that have names will be 30 out of 180, the 0 and the 0 cancel out, divide top and bottom by 3, that becomes 1 out of 6. So 1/6 of the, what percent? We want to convert that into a percent. So 1 divided by 6, I think we did that last lesson. It was 0. So equal to 16.7%, or it will be 6 recurring, 6 recurring. So 16.7% have names. Okay. Oh, I think my head kind of blocked it over there. There, can you see? Have, oh no, I can't see anymore. Have names. Okay, 16.7% have names. So moving on to question 5. A lock has a 3-digit code. Each of the digits is a whole number from 1 through 9. So 3 digits, 1, 2, and 3. Each one can be 1 to 9, 1 to 9, 1 to 9. And so we want to find the probability that the lock has a 3-digit code in which all the digits are the same number. So how many favorable events are there, outcomes are there? It's either 111, 222, 333, all the way to 999. So there's 9 favorable outcomes. So we also want to work out what are the total possible outcomes. So the total possible outcome, whoops, let me write this better. Total possible outcomes is equal to, well, how many can I choose for the first one? 9. From 1 to 9, there are 9 possible ways. The second one, also 9. The third one, also 9. It didn't say that it cannot repeat, so it's 9 times 9 times 9, 9 times 9 times 9, which will be, that's going to be 9 times 9 times 9, that's going to be equal to 81 times 9, and so 81 times 9, I just have to do some quick multiplying over here. That's 9 times 1 is 9, 9 times 8 is 72, that's 729 different possible outcomes. And so there are 9 ways in which there are 9 ways which have a same numbers. And so the probability of same numbers is equal to 9 out of 729, and then you will have to simplify that by dividing top and bottom by 9. And so if I multiplied it by 9, and then now I have to divide it by 9 again, which is 1 out of 81 chance. So that is 1 out of 81. Moving on to question 6. So I'm going to have to bring this question, the questions down. Just the question. Let me move this down. Oops. Sorry about that. Okay, question 6. Let's move on. A rectangular prism is made out of graph paper. The bases of the prism are large squares with 4 grid squares along each edge. So if we look at it, if we have graph paper, if I can quickly dot them down like this, this is one large square. Yeah, because square with 4 grid squares along each edge. So the height of the prism is 6 grid squares. The base of the prism are large squares with 4 grid squares along each edge. Yeah, so the height of the prism is 6 grid squares. 1 base and 1 face of the prism are painted blue. The prism is then opened up to form a net, and a grid square is chosen at random from the net. What is the probability that it is blue? Okay, so I just reread the question and then I understand it now. It took me just a little bit more time. And so what it's saying is that there's a prism with 4 by 4 as the base, and then the height is 6 over here. So if you look at it, that's 1, 2, that's 1, that's 2, that's 3, that's 4. The bases are 1, 2, 3, 4. And then the height of the prism is 1, 2, 3, 4, 5, 6. So that's what it means. Okay, so that's the bases, and those are the heights of the prism. And then it says that 1 base and 1 face of the prism are painted blue. So just one face and one base. So that's a base, and that's also a face. And so altogether, if we open this up, what we can see here is only half of the faces and the bases. If we look at the other side, in dotted line in red over here, there's also another face, another 2 faces, and another base at the back. And so that's the ones that we cannot see, but we know that they're there. And so in terms of grid, how many of these grids are painted blue? If we think about it, the number of painted blue is equal to, there's 4 by 4 at the top, 4 times 4, and then number of painted blue at the side, which is 4 times 6. So we need to add them up, 4 times 6. And so we add them all together, that's 16 plus 24, and all together, that's going to be 40 grids painted blue. Now, all together, altogether, how many total grids are there? So the total grids is going to be, well, there's 4 times 4, the top and the bottom, so we need to multiply that by 2. And in the face, there's going to be 4 faces at the 4 sides. And so that's going to be 2 times 4 times 4, plus that's going to be 4 times 6. And so if we work that out, that's going to be 2 times 16 plus 4 times 24. And so we'll need to continue. That's going to be 32 plus, what's 4 times 24? That's going to be 48 times 2. 48 times 2 will be 96. And so once we add those together, that's going to be 128 squares in total. So there's 128 squares in total. 40 of them are painted blue. So if we choose a grid at random, once we open it all up, what is the probability that it will be blue? So the probability of blue is equal to, there's going to be 40 favorable events out of 128 total events, outcomes. So that's 40 out of 128. And then let's simplify our answer. That's going to be 20 out of 64. That's 10 out of 32. That's 5 out of 16. So 5 out of 16. That will be our simplified answer for the probability. Moving on to question 7. I know this was a fairly complicated question. If you got it, well done. Let's move on to question 7. After a writing contest closed, the contest sponsor mistakenly sent out letters to 5% of the contest's entrants saying they had won a prize. In fact, only 0.1% of the contest entrants had won a prize. If you received a letter telling you that you had won, what was the probability that you had actually won a prize? So they sent out too many, but actually only 1%. So if we think about it, how many people have actually won? So we can imagine 1,000. Okay, let's imagine that 1,000, there were 1,000 contestants. So if there were 1,000 contestants, okay, I think I went over. Okay, there were 1,000 people. Just make it smaller. Okay, let's just say that there were 1,000 people, and so they sent out 5% winners. And so how many is that? 5% of 1,000. 5% of 1,000 is equal to 50. So they sent out 50. But in fact, only 0.1% won the prize. And so 0.1% of 1,000, which is equal to 1 winner. Of course, this is basing this on 1,000 people. It could have been 1 million, it could have been 10,000, it could have been 100,000 or more. But I'm just using 1,000 because it's an easier number. So 50 out of 1,000 people received the winning prize, but only 1%, only one person is the actual winner. And so it says, if you received a letter telling you that you had won, what is the probability that you had actually won a prize? Only one person out of that 50 people actually won the prize. So the probability that they actually won the prize is 1. The probability of actually winning is equal to 1 person out of the 50 people that won, which is equal to 2% chance, or just 1 out of 50 is fine. Just leave it at the fraction. 1 out of 50 is okay. Of course, there are other ways to do this. If you use another way and you still got the correct answer, well done. But I'm just showing us this way. Question 8. You spin the 2 spinners shown below. This time it is in color. So if you're watching this on your computer or mobile phone, it's in color. I'm pretty sure your computer screen is in color. It's not black and white. So you spin the 2 spinners shown below. is the sum of the two numbers more likely to be prime or more likely to be composite? So the result of the spinners, 1, 2, 3, 4, and 5, and 1, 2, 3. What we would want to do is this time we might want to actually use a tree diagram to show the results. So from the first spinner, we can have 1, 2, 3, 4, and 5. And then from the second spinner, each one of them, we can have 1, 2, and 3. So either it's going to be 1, 2, and 3, 1, 2, and 3. It can be 1, 2, and 3. It can be 1, 2, and 3, and it can be 1, 2, and 3. I should have utilized a little bit more space. So let me do this and just go over like this so that I can give myself a little bit more space. Oh no, we can't see the 3 anymore. So let's undo that. There we go. So what we want to do now is we want to add up our results because we want the sum. So 1 plus 1, that's going to give me 2. 1 plus 2 is 3. 1 plus 3 is 4. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 3 plus 1 is 4. That's 5. That's 6. And then that's going to be 5, 6, 7. Then 6, 7, 8. Then we want to see which ones are prime, which ones are composite. I will just highlight the ones that are prime number. So which one are prime numbers? 2 is a prime number, 3 is a prime number, 3 is also a prime number here, 5 is a prime number, 5 is a prime number, 5 is a prime number, 7 is a prime number, 7 is a prime number. And so of all those highlighted, how many are prime? So I can just quickly write down the number of prime is equal to 1, 2, 3, 4, 5, 6, 7, 8. And the number of composite is equal to 1, 2, 3, 4, 5, 6, 7. And so is it more likely to be composite or prime? So there's more prime than composite, so it's going to be more likely to be prime. And I'm sorry about that. Just hold on. Okay, and I'm back. This is what happens when I use a phone as a camera. The random people will start calling me and then it will disconnect. So I'm back. Question 9. We can see question 9 at the top over there. A bag is filled with 12 tiles, 12 red tiles, and 4 blue tiles and 6 green tiles. In which of the following cases is the second tile you choose more likely to be blue, more likely to be red? And explain. So a bag is filled with 12 red tiles, 4 blue tiles, and 6 green tiles. And so we want to find which one is more likely to be blue and which one is more likely to be red. So let's look at A first. Draw 1 green tile, then draw 1 other tile without replacing the first. So without replacing the first, meaning it's going to be dependent events. So 9A, if we're going to calculate the probability, what's the probability of getting a green and a one other tile? Oh wait, draw 1 green tile and then draw 1 other tile without replacing. Which of the following cases is the second tile you choose more likely to be blue or more likely to be red? Oh, so we want to find either green and blue, or we want to find green and red. So we'll do green and blue first. It's going to be probability of green times the probability of blue given green, because this is dependent events. And so the probability of green is going to be 6 green tiles out of 6 plus 4 plus 6, 12 plus 4 plus 6, which is 22, if I'm not mistaken, 22. So it's 6 out of 22 times the probability of blue given green, which will be 4 blue tiles, so 4 out of 21. So we want to find the probability of this. We multiply together. So let's go ahead and simplify this. That's 3 out of 11. So 3 times 4 will be equals to 12. Oh, 3 and 21 can be simplified again. So that's going to be 7. And then 4 out of 11 times 7 will be 4 out of 77. So that's 4 out of 77 for green and blue. And then we want to find probability of green and red. So that will be probability of green times the probability of red given green, which will be again 6 out of 22, multiplied by the number of red is 12 red tiles. So that's going to be 12 out of 21. And so 22, 6 and 22, that's 3 out of 11. And then 3 and 22 can be simplified again. So that's going to be 12 out of 77. So which one is more likely? Red is more likely. So red, more likely. If you can see my writing, which you cannot, more likely. Then let's look at the next part. Let me just drag this down over here. Yep. So draw one tile, put it back in the bag, and then draw another tile. So in which of the following cases is the second tile you choose more likely to be blue? The second tile you choose more likely to be blue. So sorry, I was interrupted by another teacher, Mr. Siu. He just came in and asked me something. But moving back to this question, I was just reading it again, and it says, which of the following cases is the second tile you choose more likely to be blue or more likely to be red? In terms of blue, there is no case in which it's more likely to be blue. It's always going to be more likely to be red because there are 12 red tiles compared to only 4 blue tiles. So I'm not too sure what this question is actually asking. If anyone else knows, then you can feel free to come up to me, but I will just leave that as it is over here. I'll just finish this video off. I will make a second video, which is separate, that will talk about the multiple choices and the other 2 problem solving. So that is it for this video. Tune in for another video. So hopefully you guys are studying well for your test that is coming up on Friday and Thursday, Friday. Okay, so see you guys.